This is Project 1 Video 4, the one in which I do the documentation and finishing touches. So let's work on, work on the graph first. So I got to title the graph. Let me call it. Oh, and the word title has to be in lowercase. So this is a function, a built-in function called title. It puts a title on the graph, so it's one that somebody else wrote, built into Octave, and it's the name of the function starts with a lowercase t. So what should I call it? I'm making a graph of x component of electric field versus x. That's the electric field on the x-axis. It's part of a title. I think I'll capitalize that. And I'll put x label is x in units. Put the unit symbol in square brackets rather than parentheses, so it doesn't look like it's a function of something. And that's going to be in meters. And the x label has to be in quotes, so it's a string of text. And y label, I'm going to call it E sub x. And that's going to be in newtons per coulomb. So it worked strictly in SI units. And newtons comes from the lowercase k, the coulomb constant. And coulombs we built in, plus it's in there. Alrighty, let's see how that looks. I'll save it, go to the command window and run it. Take a look at what we got. X component of electric field versus x, that's a good title. E sub x, isn't that cool? I use underscore to say a subscript was coming in. It translates it into just a subscript. So that's E sub x in newtons per coulomb versus x in meters. That's what we plotted. So we went out to 15 centimeters away from this charge distribution, which went up like 2.5 centimeters and down 2.5 centimeters. Alright, it was 25 millimeters. I think that looks good. So I believe we have this thing running. I guess I want to check one more thing. I'm going to change this from minus 0.01 to 0.01. Just to make sure it's negative to the left, and it should be anti-symmetric, I guess I'll call it. So yeah, with respect to 0, right there's the 0 line. Oops. The 0 line is here, and the 0 for electric field is there. So to the right it goes up and dies off. To the left it's leftward directed, so it goes down and then dies off as well. Alright, so it all makes sense. Let's get back to make it so that it does what the assignment said. I'm going to try clicking in here and just saying Control Z for an undo. Yeah, it seems to have worked perfectly. Alright, save it again. I think I'll run it just to make sure it does what it's supposed to do. Yeah, we're back to what it was supposed to do, so that looks good. Alright, now I think I've got the finishing touches on there. Now it's just a matter of the documentation. I got to document both of them. Oh, by the way, we note nothing's being printed to the screen here. I type in GraphX and it gives me the command prompt with no junk being printed. That just means I put in all the semicolons that have to be put in. So for some reason I feel like doing the first one first. Alright. Put a % symbol here. This is called a comment. We got to insert a comment. And I would write something like for a set of charged particles, each having a charge of 100 microcoulombs, lined up along the y-axis from minus 0.025 meters to 0.025 meters in steps of 2 millimeters. This function calculates the x component of the electric field at any point on the x-axis. And then, so what I'm going to ask you to do is to write that out in your own words. Clearly, really, and thoroughly. What the function does in your, I think I'm going to try own words. Alright. And I think what I got to do is turn word wrap on. I'm going to pause this video while I find that. Alright, I'm not actually finding a word wrap, so if line goes to, this would be off the page right here, this marker right here, along wrap it. So this does go too long, so I'll hit enter there and then %. If I can find it on my keyboard, %. So clearly and thoroughly state what the function does in your own words if the line goes too long. And then you do have to say that it's by you. Make sure you put your name, not my name. And I'm actually going to copy all of that to the other one. Your description will be different for each function, but I'm not actually writing the description, just telling you to, so mine's going to be the same in both cases. But make sure you got by Jeffrey Schneck, not by Jeffrey Schneck, by your name, by you, that you're the one that wrote it. Make sure you write it and you write down that you are the one that wrote it. Alright, input. So I'll go % input variable. So a lot of times that'll be input variables, but here we only have one. X. Which is, I think I'll put a colon there. Position along value, I think I'll call it value of abscissa, that's the X value, for point on X-axis at which E sub X is to be calculated. Alright, use your own words. If you don't use the word abscissa, then you got to say it's the x value for the point on the x-axis, something like that. But use your own words here. So if abscissa is not part of your vocabulary, please don't use it. And then that's all there is for that. I'm gonna go percent output variable percent e underscore x, and it is the x component. I think I'll say the scalar component of the electric field at point x comma 0. Give the xy coordinates of the point in question. Scalar x component of, alright, then attribution make it tell a story. I say so it's like I started the pencil on paper, and for this it's the writing of the code. I used I wrote the pencil on paper by myself. I then checked with Professor Schnick's version in video 1 and 2, or for this particular code, be just video 1, and I had to fix mine up a little bit. I tried writing the code and I got stuck, so I referred to video 2, that kind of thing. Give a whole story. Say what resources you use. I'm hoping that in a lot of cases what you do is go, so if I'd have been able to wrap the comments, I could have used that as a resource, but I didn't find anything. A good way of checking for stuff like MATLAB, if I had to look up, like if you were to do it on your own and you decided I'm just going to look up stuff rather than using the video, I'll look it up on the internet. You could do MATLAB ArrayFun if you had ran into the trouble that I had. Let's say you had heard of ArrayFun. Probably, this is what I thought I was going to have to do because I wasn't confident that I remembered how to use it. But then this is, you'd apply in the function in the called by the ArrayFun. In other words, your function on an element by element basis. So you look up here how to do it, and there's a handle to a function, and that's what why I needed the @ sign in front of it. Usually a lot of this stuff doesn't help out too much, but here's that @ sign. This is the handle to a function @ of x. It's an anonymous function, but it's a handle to it. So might have had a little trouble figuring out how to use it, but that's the kind of thing I mean. Like, you look it up on the internet, and to me the easiest way is to type in the name of the thing that you have a question about, or your guess for the name of the thing. I want to title the x-axis. Title x-axis MATLAB. and turns out it's label x-axis. So the command is xlabel, and then the text. The text has to be a string, so that's why I put it in quotes. So there's an example of it. So xlabel population, and you get population on the x-axis there. Multi-line, if you want, etc. So if you were trying to figure out how to label the x-axis, you note that you don't have to put in you don't have to know exactly what the name of the function is. You wanted to title the x-axis, so you searched on that, and it told you label the x-axis, and it told you that the command is xlabel. So that's the kind of thing that I'm hoping to see in your attribution for this first one, since you haven't had any practice with it before, or I assume you didn't. You haven't. I would expect that your attribution is mostly just going to be my videos, like you refer to project 1 video 1 and 2, etc. Like I got started on the pencil and paper, I got stuck. I looked at project 1 video 1 by Professor Schneck, that kind of stuff. But make sure you write it out. And then let's see if we need further explication of what's going on here. So it's pretty obvious what we're doing there. We'll assume that it's somebody that knows Octave/MATLAB code, knows what these things mean, so you're not explaining MATLAB syntax, but more or less saying why you're doing it. And I made this in a way that I use names like R and E, and this looks like KQ over R squared. I was thinking of combining it, putting in, go right to EX array and multiply that out. So in other words, X over R times that, so I'd have KQX over R cubed, but then that's a derived formula. It's not clear where it came from, whereas here it's obvious. Okay, this is Coulomb's law right there, KQ over R squared. You can see it. We are not showing the triangle, but a person should be able to figure out that we're talking about the angle that the vector makes, and then E cosine of theta. It's all because of the names of the variables and the way I did it using formulas that are fundamental formulas, and they're written right there. This is self-explanatory. I don't really think I have to explain anything that I'm doing. This is clearly an array of values, and it's EX. It makes sense that it's an array of X component electric field values. So choose names that tell the reader what is stored in that variable. And then let's see if I'm running off the page here. I guess not. Alright, and then you don't have to write a whole lot of comments that say, okay, now what I'm evaluating is Coulomb's law, but it's already been multiplied by the cosine of theta, which is given as X over R. I just actually write the code out that way so people can see what's going on. Alright, now I'm going to do Control S for that and get over to the other one. I think this for me is a copy. For you, I would not expect it to be a copy because you're actually telling your story for each function. But I'm just telling you that you have to write your own attribution, and you will use something. I expect if you're listening to my voice now, you use this video. Maybe you can say I did it all on my own and I just checked with the videos, but some attribution should go on there. Check to make sure it was right by listening to all the videos. So see if there's anything weird going on in here. set up an array of values, find E at all those values, and make a graph of it. And then put the window dressing on the graph. So I think that looks good. I don't trust it unless I go and use the handout as a checklist to the extent that it applies to this one. Complete algebraic solution including any diagrams, and at least one diagram. And I've got this. I got a vector component diagram, and I got this the whole situation diagram, the diagram of the configuration of the charges, including the point at which I'm trying to calculate the electric field. So I got my diagrams. I got I call it the algebraic solution. In one sense, it's different from the solution to a homework problem, because in the end you want to write down for a homework problem you write down E sub x in terms of just given quantities, and here I'm just writing it down in terms of the last thing that I solved for, because I'm programming. Sometimes it is a good idea to do more of the algebra the pencil and paper, combine things, because things simplify. But we've already visualized how they would simplify, how they would be put together here, and it doesn't simplify. We would have, if I multiplied using my expression for the cosine of x, which I found up here, if I stuck that in there and that one in there, I would have the kqx over r sub I cubed, and that's nothing cancels there. Alright, so I think I've done what they asked for in that one. I get complete algebraic solution, at least, and any relevant diagrams, at least one. I got 2, and then outline of the steps the program will complete. So this was outline 1, the outline for that function that just calculating the electric field, and then the other function is the one where I graph it using the first function. We had is ex array. When here's the first function, e sub x, or just ex. Alright, I've written it as e sub x here, but in the code I call it ex. Alright, I wanted to look at this. So I got both outlines, programming 2.m files. I got that. I'd say both of them do what they're supposed to do. Oh, and there was nothing printed to the screen. Actually, just before you hand it in, especially after typing in a bunch of comments, you should run it again and make sure that it's still working. So I'm getting the right graph, and I see that nothing is printed to the screen. So we're good there. What was next? Alright, now the documentation. A comment started on the first line of the function statement saying what the function does. Okay, I told you to write one. I gave you an example of, I said orally in words what such a statement would be like, but you want to thoroughly describe what it does. So I don't really, I've got it covered in the sense that I told you to do it as a comment, but you have to actually write out the comment. Another set of comments providing a list of the arguments. Okay, this is for each one, and I think I only did it for one of them. So let's check the editor. This one, I didn't do it really. I think I'll go input variables, none, output variables. And then somebody reading the description of it won't think that you just forgot to put that. Alright, I got to turn those into comments. So percent, just put a percent in front of each one. I'm going to go Control C, Control-V, Control-V, and Control-V. It's because it's easier to find that than the Shift%. Alright, so doing the checklist helped me out. Another set of with beside each. Okay. If there are no input variables, so that's what I just took care of. For the case of a function that returns one or more values, comments must be included that provide a list of the return variables. Okay, so input variables and output variables. State what each variable is. Alright, so I took care of C as well. For the case of anything that includes not self-explanatory. I found, in my opinion, they were all self-explanatory, and I mean, I guess somebody could have that with a super convoluted program. They could say that was their opinion, but I think it's reasonable to consider that the statements are all self-explanatory. In other words, I made the program self-documenting. I chose variable names that would tell the reader that knows MATLAB, knows /Octave, either one, and knows some physics, especially Coulomb's law in this case. They should be able to, they can see what's going on. So it's when the programs get longer and convoluted that you really have to make some, explain what's going on at various places. Explain to the reader of the code. Okay, for the case of one or more graphs, we got that. One graph. Title. Each axis must be titled with units and the name of the quantity. If there's more than, well, we only have one, so let's make sure I got everything. Up arrow to make it come up. Hit enter. And so there's the title. Makes sense. E sub x versus x. I think everything's looking good. Title, each axis title. Oh, did I have the units on there? Meters, newtons per coulomb. Yeah. Okay, I don't have to worry about a legend for this one. You must provide attribution. Get a comment. Okay. Yours can't be identical to mine. Mine is kind of screaming at you. Type your own words in here. How did I do that? I think. Write your own. Yeah. Tell a story. Say what resource you use. Alright, so if I had to look something up, like how to title the x-axis, then I would be putting something in there too. I had actually forgotten how to do that and looked it up earlier in the day, but it was before I was writing this code, so I'll consider that a known quantity at that time. I would expect for this first project that in your attribution you'll be saying which videos you watched when, while you were at what stage in the project that you watched a particular video. Don't just say refer to Professor Schnick's videos, so be more specific. Okay, so I think I'm done with the checklist. Alright, so it's these two files, you have to make sure you know how to get to them so that you can submit them via Sakai. You have to submit two files for this project number one, and for me the two files are ex.m and graphex.m. I'm going to call this the end of project 1 video 4.